Okay, so our objective is to write a custom comparator for our single cards in which we sort them by value first and then by suit. All right, so here's how we do that. We're going to write a, I don't know, I'll just call it card comparator. Oops, card comparator. And we're going to implement comparator. Okay, so we're saying we're going to implement it, and then NetBeans complains that we're not abstract. We don't ever override abstract, and the way to do that is to implement all abstract methods. You see that Java has some of these things that they've added, but we're not going to concern ourselves with right now. That, for right now, they have these default methods that they're actually implemented. I think it was a terrible idea, but that's just me. All right, so when and this is a NetBeans thing. NetBeans says, okay, I'm going to instantiate your, not instantiate, I'm going to write basically a skeleton or a stub for your method, but it's going to throw an unsupported operation exception. So I'm going to force you to actually do something with this. Okay, so compare is going to look for a return value. So let's okay, so let's start with the difference between the values. Okay, so if all of the values were different, then just as with the ints, we could return that, because they would return 0 for ones whose values are the same, and it would return either positive or negative depending on the values being greater than or equal. The problem here is that if I just return this, value, then do you see what the problem is with this? So if I give it like the 3 of clubs and the 3 of hearts, what's it going to return? 0. And so the sorted set is going to see those two as being equal. And remember that you can't have equal items on a sorted set. So those two, the 3 of hearts and the 3 of clubs, would not be able to coexist on that sorted set if that's all I did, right? And that's not what we want, right? Okay, so this is what you have to deal with when you have multiple criteria for this. Okay, so we basically have two-dimensional items, these cards. They have values and they have suits, and we want to sort them in such a way that they maintain their distinctness and yet are sorted in a particular way. And for that, we have to make choices. And so the first choice is by value. So we first want to have the value, and then now, if I have the 4 of clubs and the 3 of diamonds, it's going to return a 1, which means that the 3 of diamonds would go first. In other words, all the 3s are going to come before the 4s. In other words, the values are going to be in ascending order. The problem is that for ones of equal value, we want to make sure that they're distinguished. And so we need to make a choice. So the choice that I'm going to make here is that we're going to go clubs, diamonds, hearts, spades. Again, that's a standard order from bridge, I guess. I don't know. Again, the order doesn't matter. I mean, it's whatever you want. That's the one I'm going to choose here. So that is only come into play under what circumstance am I going to have to worry about the different suits? It was kind of a clue in the first question. In other words, if I have the 3 of hearts and the 3 of diamonds, as it sits now, they're going to be the same, but I want to make them different. So under what circumstance am I going to have to go to the suit as the secondary criterion?
When return value is 0.
Yeah, when they're equal. Or in other words, yeah, so if the return value is 0, then I want to do something that's going to fix it. Okay, so there are a number of ways to do this. What I'm going to do here is slightly unusual. I'm going to use switch statements. Okay, I'm not a huge fan of switch statements, but in some cases they're fairly useful. Okay, so first I'm going to switch on the suit. And again, this would be a whole lot easier if we had enums, but again, that's part of the reason for this example is to show you how these things can get complex and how maintaining these rules can be a bit tricky. Okay, so clubs are going to come before everything. So if I'm a club, now here's the thing. If I have to, now I'm assuming that that I don't have a pinochle deck, because nobody plays pinochle anymore, right? Exactly my point. Yeah. Pinochle is a game where there are 48 cards, but they don't have all of the same values, but they have 2 of everything. Like I said, nobody plays it anymore, so it's kind of like that restaurant that nobody goes to anymore because it's too crowded. You know that one? Okay, so if the values are the same, then I know that the suits must be different. That's the only circumstance in this case, and under which they're going to be different. So if the first one is clubs, then that means that it's going to be less than all the others. So then I can set the return value to -1. And then just to be complete, if it's any of the others, oops. Then oops. Okay, now in this case I'm using that property of switch statements that I was complaining about before that causes everything to drop through. So in other words, what's happening here is I don't need to have a separate one for diamonds, hearts, and spades because I know that, actually I do. So if it's a diamond, then what I'm going to do is I'm now going to do a switch on the second one. And this is why strings can be a pain in the butt. So if I'm a diamond, then what I return is going to depend. If the other one was a club, then I know I'm bigger than that. Oops, I say I don't want to return. See, there are some. One of the things about writing methods, and the reason I'm focusing on this thing right here, is that ideally, and every now and then you can maybe break this if it's, but particularly in what's going to be a long method, you want to have one return statement at the very end. In other words, you don't want to be breaking out of returning from your method in the middle. because that makes debugging really, really hard, because it makes for kind of spaghetti-like logic. So here, regardless of everything, the return is always going to be at the bottom. And the way I do that is I have this local variable called return value, which if they're different, it's going to skip all of this stuff and go all the way to the bottom. But here, okay, so what's happening here is that because clubs come before diamonds, I'm putting the return value at some positive, and if I'm a diamond and the other's a heart or a spade, then I come before them, and so I return a -1. Okay, so now I do the same thing here. Okay, only now I'm a heart. Yeah, and then notice here, see, okay, I said, if I said I'm a club, that means I'm before everybody. If I'm a diamond, notice I didn't have to consider the case where the other one was a diamond. Is that clear? So why didn't I have a case for diamond here?
You can't show the same face card with the same value.
Yeah, that's the constraint, that there's going to be only one value of diamonds in this case. And so if the value comes in at 0, that is, if the two values are 0, then they must be of different suits. So I don't have to worry about the, again, it wouldn't hurt, but it's never going to happen. Okay, so now if I'm hearts, then my two cases of the ones before me are hearts, clubs, and diamonds. Okay, so if I'm a heart and they're a diamond, that means that my return value is going to be 1. On the other hand, if you're a spade, okay, and then you got to be careful here. If I don't break, then weird stuff is going to happen. Okay, and then finally, if I'm a spade, then that means that I can always return, that means I'm going to always come after everybody else. So my return value is going to be 1. Now I think, notice there's nothing up my sleeve. So there's a positive probability that I screwed something up here. And if I did, I'm going to find out, hopefully. All right, so let's test this out. And here's how we can test it. See, and this is where we can kind of reuse some stuff. So basically, remember we had this card deck. So, I mean, you think, well, now I have to kind of do a whole bunch of work. The programmer virtue of laziness says I've already done the work. So my card deck has already created a full deck of cards. Okay, let's just make sure it's working. Okay, so, and you all have this. This was one of our early examples. So here's a full. So we know we're playing with a full deck, at least as far as the program is concerned. In all others, it's whatever. Okay, so we know that we're actually getting it. So here's how we create our sorted set. And it's going to contain single cards. So and remember, sorted set is the interface, tree set is the concrete one. And well, here, if again, just let's just sort of get them as a remember, get my cards. Okay, so that's going to give me an array. Now I want to be, again, I'm lazy. I don't want to write a for loop. So what I will do is first create a list. And this use arrays as lists. Again, I could have done this in a fewer steps, but just wanted to show you what the intermediate steps are. And now I can add all of those to my tree set. And now to print them out, in what is it, sorted by value. Okay. Now I have kind of pulled one over on you. We're going to get a runtime exception here, just to illustrate. Okay. But this was deliberate. Okay, so what was the problem? Again, the things in red, by the way, come out to a separate thing. Yeah, so the actual exception was up here. So exception class cast cannot be cast to comparable. So what's the problem? The problem is that when it went to compare things, before it compared them, it tried to cast it to a comparable. And of course, single card doesn't implement comparable. So what went wrong here? What went wrong, and that was deliberate, just to see if you were paying attention. You see what went wrong? So how do I fix this? See, what it's saying is that tree set doesn't like single card because it can't cast it to comparable. But I just did all this work writing this comparator, and it's still giving me a runtime error. So how do I fix it? Or what did I not do? I wrote this comparator, but I didn't tell my tree set about it. So if I just instantiate a tree set without anything, it's going to expect comparables. In fact, you have a little glimpse into what it's doing is that by default, it says, okay, you didn't give me a comparator, so I'm going to assume you're just putting stuff in here that belongs, and it belongs if it's comparable. And so I'm going to cast it to a comparable, but then, in fact, we can kind of see what's going on here. Here's the cast, and what it's saying is, again, this is an example of the kind of code that I don't want you to write, because this is far too clever for its own good. I mean, it's a little bit undecipherable unless you really look closely into it. What it's doing is that it is casting. See, notice it's got its own compare method here, but it's sending in objects, and they're comparing them to comparable. It's casting, trying to cast, this is where the cast is. It's trying to cast it to comparable. All right, but I didn't tell my tree set about my wonderful comparator. And this, so how do I do that? I pass it to the constructor. Remember, a tree map has a number of different constructors. One is the empty one will give me an empty tree set. One is if I give it a collection of things, it'll take whatever is in that and copy them in. Or, in this case, it's looking for a comparator. And again, when we talk a little bit more about generics, we'll dip our toes into this. And this question mark super is generic ease in Java. But not to worry about that for the moment. See, we're giving it a comparator now. And now it should work, unless I screwed up. Okay, so let's see. So here we sorted by value. So here we have the aces, clubs, diamonds, hearts, spades, then all the deuces, then all the threes, all the fours, 5, 6, 7, all the way up to kings. Okay, so the objective was to sort them by value first, and then by suit. And so, fortuitously, I didn't screw up on that, apparently, because it seems to work. You know, how do I know it works? Well, first of all, I'm not losing anything. In other words, if you accidentally, it's easy to kind of accidentally lose some things. And if it's easy, in other words, if things kind of come out zero where they shouldn't, then I'll start losing some things. Remember when I said if we only compared the values, then I would lose some things because I'd only get one value for each suit. The other place to kind of watch for stuff is this consistency. If these are not consistent, then the results are unpredictable, and you will not actually get runtime errors, but you will get really weird results. Okay, so that's how to write. Okay, what have we done? We've taken a situation where we have two criteria. So when you're sorting in 2 dimensions, you have to make a choice. You have to say, well, what's the primary key, as it were? What's the first criterion? In this case, I chose value. Well, what's the second criterion? Well, in this case, it was suit. And because suits were strings, we had to go through all this weird dance right here. Maybe at some point we'll do that with E. See, with enums, we could do this much more quickly. Because if we defined our enums, in fact, let me just kind of do that. So let's, okay, I'm going to call it a suit. And so by defining an enum like this, what these do is because each enum has its own value, I can get that value through ordinal. And so if I had defined, instead of strings, these suits, then instead of going through all this dance with the strings, I could have simply compared their ordinals. Okay, now, let's see. This was sort of for numbers. Any questions about this? The main thing here is that this compare method was a lot more complicated than that very simple one that we introduced ourselves with. There are a lot of places here where there are a lot of potentials for making mistakes. So this is that's why I wasn't sure that without checking my notes that I'd be able to kind of do it, but again, just following the logic in each case. Again, the idea was to just keep in mind what the criteria were and what I could assume in each situation. So again, to recap, first I was looking at the values, and if the values are different, then because that was my first criterion, my first key, then I could just simply bounce out all of that and return it, because I knew that all the 3s are going to be less than all the 10s. But if they are the same, then I need to, all this stuff in the middle is just comparing by suits. And I'm kind of looking at these strings. These strings are kind of a pain, but nevertheless. Okay. So, and what this showed was that even though our single card did not implement comparable, and we saw what would happen if we tried to put it on a sorted set, that isn't a showstopper. If I want to take something that is not comparable, and there's a reasonable way to put them in order, then I can do that. All I need is that reasonable way. Okay, so now in the last minute, I want to look at strings. All right, so now strings are comparable, and so I can put them on a sorted set. Again, tree set is the only the string. He'll be watching me. Okay. I think so. Okay, so all right, so I added 4 strings to a sorted set, and this is how they sorted them. Actually, here, let me add another one just to. Okay, do you see what the default way of sorting strings is?
Uppercase alphabetical and lowercase alphabetical.
Exactly. That's what it does. Why? Because that's the easiest way to do it. I mean, it's basically lexical rather, so it's not strictly alphabetical, right? So now, in some cases, that's fine. For example, I think this is in some Linux or Unix platforms. If you do a directory, if you list the files in the directory, it lists them this way. It lists all the caps first and then all the lowercase ones, which can be confusing. I think Windows and Macs mix them all together, in other words. So and we're out of time today, but now the question is, supposing I have a whole bunch of strings and I want to, I don't like this. I don't like this all caps first and then all lowercase. I want to have all the ordering be alphabetically regardless of case. So, well, how will I be able to do that in just sort of the broadest terms? How will I be able to sort things so that it doesn't look like this? So that this should be up here, and then maybe these two kind of next to each other. So in the most generic ways, what can I do?
Just make them all uppercase.
Yeah, that's now remember, like, when you're writing programs, you want to be, how should I say, it's like you don't want to impose unnecessary constraints on your users. So yeah, that would solve things for the developer. But the user says, hey, I want things with lowercase in them, right? So that doesn't do that good. So first of all, what this shows you is that the default compare method for strings does it like this: uppercase first, then lowercase. Why is that? Because the uppercase letters have lower character values than the lowercase ones. And we're going to have to kind of look at what that's about. But if comparable doesn't do what you want, then write a comparator. Okay, so we're going to have to write a comparator, and we will do that next time.